Good morning, class 11. In the last session, I began with the chapter classification of elements and periodicity in properties, wherein I explained you about the modern periodic table, its layout, how the periodic table, the long form of periodic table appears, and also I told you the division of the periodic table into 4 blocks, S, P, D and F block, and the shortest period and the longest periods. The 6th and 7th are the longest periods, and also told you about the calculation of atomic number. If you can simply remember this series 2, 8, 8, 18, 18, 32, 32. And one more thing, children, I told you to find out this 7th noble gas which has been recently discovered and added to the periodic table, and I told you the name of that noble gas also. The name of that noble gas is organoson, and I hope you people have tried to do some research or study on this element. So this element basically is abbreviated as OG. So the one who has gone through this element must have come to know about this abbreviation or Iupac nomenclature of this element organoson, which is OG. And now if you have to find out the atomic number of this 7th noble gas which is present in the 7th period of the periodic table, then it will be, how will you calculate it? 86 plus 32, because the 7th period has 32 elements. So if you add 32 to 86, you'll get the atomic number of this element as 118. And how it is spelled as organoson? This is spelled as OGANESSON. Okay, so now we have in total we have 7 noble gases, rare gases in the periodic table. And the interesting fact about this element is, in total we have 118 elements in the periodic table. So obviously organoson or OG occupies the last position of the periodic table. That is, it is the 118th element of the periodic table. So children, this, if you remember this, it would be better for you. Try to remember the names of these noble gases, these 7 noble gases, and also if you remember the names, it will be easy for in order. If you remember the names, it is more important to remember the names in order, so that you can find out the atomic number also of these noble gases. With the help of the atomic number of these noble gases, you can find out the atomic number of other P block elements. And one more thing, when you write the electronic configurations of the elements with higher atomic number, then it would be convenient for you to round off that electronic configuration up to the nearest noble gas, and obviously it will become shorter and easier for you. So children, first of all, the first thing that you will do in this chapter is to remember the names of these 7 noble gases along with the atomic number. And atomic number, I told you the method of learning these atomic numbers with the help of this series. Now moving ahead with the introductory portion of this chapter. So here are some important points that you can note down in your notes. You can add these points to your notes. The elements with similar characteristics are grouped together, and this process is known as classification of elements. And why it was necessary to classify these elements into groups and period? In order to make the study of the elements easier and convenient. Because it is not possible for us to remember the characteristics, the properties of 118 elements. But when we group them, when we group the elements with similar properties into various groups, it becomes easy for us to remember the properties of the groups. So you know, as I told you, as at present as many as 118 elements are known to us. So remembering the properties of each and every element became difficult. So the elements with similar properties were grouped together by the scientist. So the classification of elements means the arrangement of the known elements in certain groups in such a way so that the elements with similar properties are grouped together. Now when they are in the groups, that is, like here I mentioned that this is group 1, this is group 2, group 3. So this much you must have done in your junior classes also, children. Like group 1 elements are known as alkali metals. These are known as alkali metals. Now why they are known as alkali metals? Because they form alkalis when they are added to water. Similarly, group 2 are known as alkaline earth metals. Group 17 elements are known as halogens. So when you observe the elements present in a particular group, they behave more or less in the similar manner. Their properties do differ to a very little extent. Otherwise, overall, if you will observe, you'll find that they have similar property. So when you remember the properties of the group, you can remember the properties of the elements present in that particular group. So that is why it is convenient for us to remember the properties of the group instead of learning the property of each and every element present in the periodic table. Now coming to the next very important head, that is periodicity in properties. What do you mean by periodicity in property? Periodicity means the repetition of properties. It means the repetition of properties of the elements after certain gaps of atomic numbers, that is elements with similar properties shows repetition at regular interval. That is, after some time you will notice that the element with similar property repeats itself. Like if you start from this hydrogen, after hydrogen next will be helium, atomic number 2, and then you will have sodium, and then again after filling this entire period, after hydrogen you will have lithium. Okay, and then below this you will have sodium. Now if you will compare the property of lithium and sodium, you'll find that their properties are more or less similar. So similarly, after sodium we have potassium. Potassium and this sodium shows a lot of similarity in its property. Both are very reactive, highly reactive elements. So you will observe that after certain interval of time, the elements with similar properties repeat itself. Okay, so that is why they are grouped together in a particular group. Now coming to modern periodic law and the present form of the periodic table, which I have already discussed with you. It was given by Henry Moseley. Atomic number was the base of classification. And what is modern periodic law? This you must have done in class 10 also. Modern periodic law states that the physical and the chemical properties of the elements are the periodic functions of their atomic number. That is, the physical and the chemical properties of the elements depend upon their atomic number. We have in total 18 groups, 7 periods and 4 blocks. Now coming to the notation for Iupac nomenclature of elements. Now children, we have to nomenclate the elements above atomic number 100, and for that we need to remember certain notations. Okay, for number 0, the notation used is nil. For 1 it is un, for 2 it is bi, for 3 it is tri, for 4 it is quad, for 5 it is pent, for 6 it is hex, for 7 it is sept, for 8 it is oct, and for 9 it is n, ENN. Now how will you write down the name of the elements with atomic number higher than 100? Now if you have to write down the name of the element, Iupac name of the element having atomic number 101, that is 101. You learned here that for 1 we use un, for 0 we use nil, un, nil, and for 1 again we use un. So it becomes un, nil, un. And as suffix we use IUM everywhere. So the name becomes unilunium, or whatever you want to call it, unilunium. For 102 it will be unilbium. I hope it is clear. I am simply using these notations to write down the nomenclature IUPAC of these elements. For 103 it is uniltrium. For 104 it becomes unilquadrium. Similarly for 105 it will be unilpentium. For 106 it will be unilhexium, unilseptium, uniloctium, unilenium. For this it will be unnium, and for this it will be unnium. For 112 it will be unbium. For 113 it will be untrium. For this unquadrium, and similarly you can write down the IUPAC up to 118. Now how will you write the symbol for these elements? So remember, we take up the initial of for each digit which has been used. For 1 un is used, for 0 nil is used, again for 1 u un is used. So I am taking u n u. So the first letter is written as capital letter and rest of the two are written as small letters. So it becomes U, capital U, N, U. Similarly for 102 it will be capital U, small n and small b. Similarly for this, capital U, small n, small t. So likewise you'll write the symbols for all 118 elements. It was given earlier because when the elements were arranged in the periodic table, all the elements, that is all 118 elements, were not given an authentic name by IUPAC. Like today we have the names of all 118 elements, but before the discovery of the names of the elements, this type of method was used for nomenclating the elements above atomic number 100. But now we have the names of all 118 elements. But since it is the part of your syllabus, you must know how to write down this IUPAC name and also the symbol. Okay, but if you will see the current periodic table and if you compare it with the periodic table of 4-5 years back or 2-3 years back, you can find the difference that 113, 115, 117 and 118, these elements did not have any specific name given by this IUPAC. IUPAC is what? It is the organization which is authorized to give the nomenclature to any chemical compound, any chemical element. It is the organization, International Union of Pure and Applied Chemistry. Okay, unless any name is approved by IUPAC, you cannot call that element or that compound with that particular name. So I hope it is clear. So you have to remember this method also, and it would be better if you remember the name, the current names which is approved by IUPAC and added to the periodic table. You don't have to learn everything together with you'll proceed further with the chapters. When you will do specifically S block, P block, D block and F block, it will become easy for you to remember the names. But for now, try to remember as much as you can, but don't take it as a pressure. So now moving ahead with modern periodic table, which is the long periodic table. As I told you, there are 3 short periods. First period with 2 elements, second period with 8 elements, the third period again with 8 elements. Then we have 4 long periods having 18, 18, 32, 32 elements in it. Now coming to the electronic configuration and the types of elements. This is again a rough layout of the periodic table. As I told you, group 1 and group 2 is the S block, group 3 to group 12 is the D block, and 13 to 18 is the P block, and then at the last we have this F block element. Now this is the general electronic configuration of S block element, Ns 1 to 2, and for D block it is N-1 D 1 to 10, Ns 1 to 2, Ns 2, Np 1 to 6 for P block. For F block it is N-2 F 1 to 14, N-1 D 0 to 1, and Ns2. For now you simply add this to your notes. I will explain you how do we get these electronic configuration. So the long form of periodic table has also been divided into 4 blocks known as SPDF. This I have been discussing with you since the 2 sessions. So till now children, try to make notes on these topics that I covered up today, and I'll be taking up separately the details and the characteristic properties of the 4 blocks in the next session. Till then, try to go through the video, and in case of any problem, feel free to ask your doubt. Thank you children.